Good evening to all of you. This is YRK Mohan, Race Academy, Bangalore. As you all know, today is chemistry CET examination. Also came like the previous other subjects out of syllabus, deleted syllabus chapter questions came in chemistry. I've calculated, but I got 16 out of syllabus questions, 15 to 16. If anybody considered one question, around 25% of the questions in this case K-CET, Karnataka CET examination, chemistry examination, 25% questions means 15 questions out of 60 questions came from deleted syllabus. From deleted syllabus in the sense means yes, hydrogen chapter and hydrogen chapter question, if you just take into consideration of S block elements, that is also removed. So S block elements one question, hydrate question from hydrogen chapter, and S block elements nitrates question one question came. And after that from environmental chemistry chapter first year that one question, and surface chemistry two questions came. Like that of I have calculated the number of questions in which what are the chapters here, and one question from the metallurgy almost yes, two questions came, and environmental chemistry one question came. Surface chemistry, yes, surface chemistry we have colloidal solutions, we have two questions. Surface chemistry colloids one question came. Hall Herald process from the purification of metals, that one aluminium, that one came. And not only that one, if you just go into the analysis of the remaining questions here, yes, polymers chapter around two questions came. And from the chemistry in everyday life chapter question one question, two questions came. And coming to the another one, we have states of matter one question from van der Waals expression came. And after that we have a question, three questions from solid state came. So and approximately 15 to 16 questions, I can say that those questions came out of syllabus. Okay, leave about this out of syllabus questions whatever are there. We will try to discuss about the questions which came in the present regular syllabus what we have. We will think about whether the KEA Karnataka Examination Authority is also going to take up the objections from the students online shortly, and after that they will decide whether the grace mark should be given or not, and all they will decide it. So let us move on to the examination question paper discussion. In this first question from the D-1 code I have that in the reaction between moist SO2 and acidified permanganate solution, there are four options given, in which usually whenever they given SO2 in the presence of KMnO4, particularly KMnO4 given, sulfur dioxide will convert it into its highest oxidation state sulfate. It means sulfur dioxide is converted into sulfate, means this information is called oxidation. That means oxidizes. Sulfur dioxide oxidizes to give sulfate. At the same time, potassium permanganate, in which permanganate is converted into manganese Mn2 plus, that is called reduction. So permanganate MnO4 minus is reduced to Mn2 plus, whereas SO2 is oxidized to sulfate. So that is the correct explanation of that question number 1. Is the first option for that question is the right option. Whereas if you see the question number 4 in D1 code we have, in that which of the following halides cannot be hydrolyzed? The most important question we can say, halides of the fourth group, carbon, silicon, germanium, whatever tin are there, right? Tin are there. Their halides are CCl4, SiCl4, GeCl4, SnCl4. The question is, if they subjected to hydrolysis, most of them are replacing that whatever the halogen with OH, but whereas CCl4 does not undergo this hydrolysis reaction. Reason is nothing but carbon is not having the available empty d orbitals for the reaction. That means carbon is not having vacant d orbitals. So no vacant d orbitals, with central atom carbon. That is the reason behind the hydrolysis. That means the hydrolysis of carbon tetrachloride is not possible. That is the right answer. CCl4 is the right answer for that question number 4. Next, we'll see question number 5. Question number 5. This is actually asked from practical chemistry, that is analysis of as a basic radical. In the third group analysis of basic radical, third group analysis of which radical? Basic radical. They are asking why we are going to add ammonium chloride is a solid to ammonium hydroxide as a reagent in the third group analysis asked. Means it is almost somewhat related to our common ion effect of the depression or suppression of the dissociation of weak electrolyte. That is the answer for that one. So why we are adding NH4Cl2? This one. So what is NH4OH? Is nothing but it is a weak electrolyte. So weak electrolytes are going to dissociate very slowly in the solution into their corresponding ions. So meanwhile what we are doing is we are doing an addition of NH4Cl, and that makes the solution a strong electrolyte solution, and the strong electrolyte with the common ion is going to completely stop its ionization in the reaction. That means in the solution the ionization of weak electrolyte will be completely suppressed. Thereby we will get a precipitate and all these things, which is one of the important thing which is discussed in the question number 5. That means question number 5 is practical based question. They have asked practical chemistry question asked. Whereas question number 6, if you take solubility of product of CaC2O4, that means what is solubility product formula? Symbol KSP that they given for CaC2O4. What is CaC2O4? Is nothing but calcium oxalate. Calcium oxalate is AB type of salt whose solubility product value which is given to us in the question is 4 into 10 to the power of minus 9, that to mole per liter whole square. Mole per liter whole square they have provided to us. So in this question, what is the aim of the problem is to find the solubility of this calcium oxalate. This question, that means whenever KSP is given for this type of AB type of salt, usually what is KSP is S square. S is equals to root KSP. That means square root of the solubility product given to us. If you calculate properly, then you will get that value. That value is called solubility of this calcium oxalate in the solution. Then what is S value? Solubility is equal to square root of KSP. That is equal to square root of 4 into 10 power minus 9. So 10 power minus 9 is there. Minus 9, if you just take it root, then it will be very difficult. So you make it even number, either 10 power minus 8 or 10 power minus 10. Better to do 10 power minus 10 by taking this is 40 into 10 power minus 10. Then you will get root 40. 10 power minus 10 will come out into the root, will become 10 power minus 5. Root 40 means it is not 6, it is not 7. In between that around 6.3 will come. We have 6.3 into 10 to the power of minus 5 moles per liter, which is the correct value or the solubility product of this calcium oxalate. Okay. So this is the question number 6. This question asked from this ionic equilibrium chapter, first year syllabus. Let us move on to question number, next question number 7. See the question number 7, and the question number 7 what they have given here is nothing but in question number 7 we have in the D1 code, that is one equation they have provided, equilibrium type of equation reaction, PCl5 decomposition reaction, giving PCl3 plus Cl2 in gaseous phase, rate and rate constant of this reaction given. So once they are given rate, the rate we can collect, that is 1.02 into 10 power minus 4 moles per liter per second is the rate value given to us, and rate constant value also provided to us, that is equals to 3.4, that is 3.4 into 10 to the power of minus 5 second inverse. So from this rate constant units, we are able to understand that the given equation is the first order rate equation, first order reaction. That means what is rate for the first order reaction is rate is equals to K into concentration of reactant power 1. And the aim of the problem is nothing but molar concentration of PCl5. That means this is concentration of PCl5 you have to calculate. That means square bracket of PCl5 is molar concentration of PCl5 will become equals to rate by rate constant. So what is the rate value given to us in the question is 1.02 into 10 to the power of minus 4 divided by 3.4 into 10 power minus 5. Usually 10 power minus 4 by 10 power minus 5 will become 10. That means 1 by 3.4 into 10 will come. Obviously we can say 3.5 into how many times? 3 times. It is not particularly exactly 3 times. It is close to a number. Yes, 3. We can write 3. So approximately it is 3 km. That is 3 moles per liter is the answer. So this will be taken as 1.02 if you want to know correctly. So this is the answer for question number 7. This is question number 7. Next, question number 8. When it comes to question number 8, is very interesting and easy question they have asked, that which of the following does not represent Arrhenius equation. First of all, Arrhenius equation in the chemical kinetics is given to us is nothing but rate constant K is equals to pre-exponential factor A into S e power minus EA by RT. So this is the one formula given. This is the exact formula what we have learned in the syllabus. Along with that one, they are given some other logarithmic forms. Ln K given to us is equals to minus EA by RT plus ln A, which is also provided to us in that options. And one more thing, if you apply log base 10, then this will become log K, that is equals to log A minus EA by 2.303 RT. So these all three are there. Whereas one thing they are given, K is equals to A into e to the power of EA by RT, not minus not given. So this is the wrong one which you need to identify in the options. So this is these are three whatever that values expressions are there, they are working good, but this is not correct, which you have to identify. Next, moving on to the next question, that is question number 14. So why I am saying it is question number 14 is nothing but 9, 10 came from that colloidal solution. 9, 10, 11 colloidal solution chapter 3 questions came. After that metallurgy chapter 2 questions came, and 14th question we are seeing, that is NO2 gas. About NO2 gas, what is NO2 gas? Nitrogen dioxide. So as you know, it is a odd electron species, definitely is having color. It's a brown color and acidic nature. So we will going to check with this color using the odd electron information. So odd electron is there, that led to the color. Actually color of this one is brown color, and this will be identified in the lab with the acidic radical discussion in our practical chemistry. So that is also is present in acidic medium. So in acidic medium, this is going to exhibit this type of color. Concentrate H2SO4, we will add whatever the gas brown color vapors are coming, that vapors you can assume NO2 gas. So that is the question number 14. Coming to the question number 16, interesting question. Why 15 we are not doing is 15 they have asked about The oxides of nitrogen, acid rain discussion and all they are given, ultraviolet, ozone depletion and all discussed in the statements. So that is out of syllabus. Next question number 16 we will see. Question number 16. What is question number 16 is there? Correct decreasing order of boiling point of hydrogen halides. That is from P block element chapter. Hydrogen halides we have HF, HCl, HBr and HIR present. These four are present. In these four, they are asking what is the boiling point order. Usually what we think is nothing but boiling point is said to be directly proportional to the molar mass. In such a case, if you just try to write the usual discussion, HI greater than, HBr greater than, HCl greater than HF, which is also available to us in the options, but this is not the right option for boiling points. Why? Because here we have a striking aspect, one of the peculiar chemical bond which is existed between hydrogen fluoride molecules that makes the hydrogen fluoride exhibiting highest boiling points in the list. So that becomes exactly HF greater than HI. So HF is having higher boiling point than HI, greater than HBr, greater than HCl. This is the correct boiling point order. Correct order of boiling points in hydrogen halides. This is the right order which they have asked. Third option is the right option for this question. This is our question number 16. Whereas if you just go with the question number 17, where 17 question is an interesting question which is they excellently designed in this examination, that is a synthetically produced radioactive noble gas. We have radioactive noble gases are there. What are noble gases? Helium, neon, argon, krypton, xenon, radon. Up to here we learnt. But what is atomic number here? 2, 10, 18, 36, 54, after that 86. If we want to know what about the next one will be if we add 32, it will become 118. It is organism, OZ. Its name is OZ, organism. So actually regarding this one only, that question actually asked, that question number 17, recently discovered noble gas organism. And in this, whatever the question asked is nothing but radioactive collision. The collision between californium and calcium. Californium given 98, californium 249 given, and which is colliding with another nuclide, that is 20 calcium 40. 20 calcium 48 given. Actually, this is 48 given, 40 only. Okay. But here mentioned it's 48. Yeah, we will take 48. And what will come, we will check it. 90 plus 20, how much? 118. That is organism. And 249 plus 248. So 48 plus 48. 48 plus 48 is 94. 295 it came. Plus here, when that atomic numbers are same, then what is this one number is 0, N1. So we have 9 plus 8 is 49. 9 plus 8 is how much? 7. So this one is so 1 extra came. So that you have 48 only it will be, I think. Yes, 248. Then what is 48 plus 48 is 96. Here 295 came. Here 1 came. Neutron. In such a case, how many neutrons are required here? Suppose you have one number came, let's just a minute, 249. Yeah, okay, let it be 49, and 49 plus 47, 48 is how much? We have 97. In this we have 294 came. 294 came. Remaining 3 are balanced with 3 neutrons. Okay, this is actual discussion. But in this, no need to go up to this level. You just simply observe what is the next one is 98 plus 20. Automatically, when the bombardment or collision of two nucleides in the nuclear reactions, neutrons also will be produced, 3. So 3 neutrons are produced, and this 118 came, which is actually organism that they have asked synthetically produced radioactive noble gas is what organism recently discovered noble gas, which is somewhat difficult, 50% difficult, 50% easy only. Without knowing this equation also you can find out if these atomic numbers are added, then you will get a number. That number you can expect in which group it is present. Noble gas next to 86 what is there, that you can go with that. If you know that symbol properly, then otherwise definitely will feel that the question is little difficult. Next, question number 18. I'll go to the question number 18 now. What is that? Is a transition element present in mixed metal. It's a alloy formation. Mixed metals are there, and in this mixed metal, what is the metal given to us is mixed metal. In this, lanthanum element is there. Lanthanum element is around 94 to 95% is there, and the alloy, and in that remaining is 5% is iron is there. Remaining 5% is iron is there, and trace amounts of the other elements are there. Other elements are trace amounts: sulfur, carbon, silicon, calcium, aluminum, etc., etc. So the question is, what is the element? 5% element asked in that mixed metal is iron. This is also somewhat difficult if you are not properly prepared the alloys and their discussion. So lanthanide elements forms alloys. That alloy mixed metal is one alloy which is already prepared for board examination. Then it is no issues at all. With this question we have question number 18. Next, question number 19. What is the question number 19 is match the following. They have given Zn2 plus in one column and Cu2 plus in the same column, and below that Ni2 plus they are given. There are some D block elements and their corresponding ions given in one column. In the other column they are given D8 configuration, which is colorless also, which is mentioned in the other column. The last one they have mentioned mu is equals to 1.73 Bohr magnetons. So if you see this one, as you know, transition elements are colored, which is non-transition element, that you can go with that colorless. That is colorless. Zinc is colorless. Copper ion is there, which one unpaired electron is there. If you calculate the mu value, it will come root 3. Root 3 is 1.73. Nickel plus 2 electronic configuration is D8. So nickel is D8 configuration, which is the match the following of this question number 19. Next, moving on to the question number 20. Question number 20. Which of the following statements related to lanthanides is incorrect? Which is the following statements regarding to lanthanides is incorrect? They are given. Means in that lanthanides are silvery in white soft metals. Yes. And samarium shows +2 oxidation state. Yes, samarium, cerium, praseodymium, samarium, promethium, samarium. This list, samarium is exhibiting +2 oxidation state, whereas cerium +4 solution is widely used as oxidizing agents in titrimetric analysis. That is also most important and correct statement only. Whereas color of lanthanide ions is due to DD transitions, because lanthanide ion is there, the ion is colored due to, the reason is not DD transition, FF transition. The electron is undergoing transition between two F orbitals. That means if they have given DD transition, you might have suspect that statement to give the correct marking of that one. That is the right option. That they are given in the statement is DD transition. That is the right option. Which incorrect statement we have to find out in that question number 20. That is also correct. Okay, we will see the remaining questions in the another session. Thank you.